For thousands of years, humanity has looked upward at the night sky and asked one question. How big is the universe? It sounds simple. A child can ask it. But the answer is so enormous, so mind-bending, so far beyond anything our senses can comprehend, that even today's most powerful minds struggle to truly grasp it. Tonight, you're going on a journey across space, time, creation, destruction, light, darkness, and the edges of existence itself. This is the full story. How big the universe really is, and what lies beyond everything we know. Chapter 1. The universe you think you see. When you step outside on a clear night, you may see a few hundred stars. That tiny sprinkle of light, those dots glowing quietly above you, are just a microscopic fraction of what's actually out there. With the naked eye, you're blind to billions of distant stars, thousands of galaxies, vast clouds of gas and dust, invisible radiation, objects that no human will ever see directly. But even if your eyes could suddenly gain infinite sensitivity, even if you could see all wavelengths of light, from radio waves to gamma rays, you would still see less than 1% of the observable universe. Why? Because most of the universe is hidden. Some objects are too far. Some are too dim. Some are moving away faster than light can reach us. And some can never be observed due to the expansion of space. So the universe you think you see is not the universe that exists. Chapter 2. Light, the slow messenger of the cosmos. To understand the size of the universe, you must first understand light. Light travels extremely fast, 300,000 kilometers per second. Yet compared to the scale of the universe, light is painfully slow. When you look at the sun, you're seeing it 8 minutes in the past. Look at Alpha Centauri, the nearest star system, and you're seeing it 4 years in the past. Everything in the universe is a time machine. The farther we look, the older the light. Look 100 million light-years away. You see galaxies from the time of the dinosaurs. Look 10 billion light-years away. You see galaxies forming in the early universe. And ultimately, we reach a wall. The edge of the observable universe, 46.5 billion light-years away. Not because nothing exists beyond that, but because that's the farthest light has had time to reach us since the birth of the universe. Chapter 3. The observable universe, a cosmic bubble. If the universe has existed for 13.8 billion years, why is the observable universe 46.5 billion light-years in radius? Because space itself is stretching. Galaxies did not physically travel 46 billion light-years. The space between us and them expanded, carrying them farther and farther away. So imagine yourself at the center of a giant cosmic bubble. This bubble is your observable universe. Everything you can ever see lies inside. Everything you can never see lies outside. The diameter of this bubble, 93 billion light-years across. That's 93 billion years for light to cross. 93 billion years of cosmic history. 93 billion years of star birth, star death, and galactic evolution. But even this gigantic number is only the beginning of the story. Chapter 4. The Milky Way, our island of stars. Before we fly to the edge of the universe, we must start at home. The Milky Way Galaxy. It's a vast, rotating island of stars, dust, and dark matter. 100,000 light-years across. 200 to 400 billion stars. A supermassive black hole at the center. Spiral arms filled with newborn stars. If you traveled at the speed of light, it would take you 1 second to circle Earth, 8 minutes to reach the Sun, 100,000 years to cross the Milky Way. Even our galaxy alone is beyond anything you can physically experience. Yet the Milky Way is just one galaxy among trillions. Chapter 5. The Local Group, our galactic family. The Milky Way is part of a small cluster called the Local Group. It includes the Milky Way, the Andromeda Galaxy, the Triangulum Galaxy, and over 50 smaller galaxies. This entire family spans 10 million light-years. But again, tiny. Because the local group is part of something even larger. Chapter 6. The Laniakea Supercluster. The local group is one cell in a cosmic organism called the Laniakea Supercluster. This structure contains 100,000 galaxies, stretching 520 million light-years across, all flowing gravitationally toward a mysterious region called the Great Attractor. Think about that. The Milky Way, enormous beyond imagination, is a dust particle inside Laniakea. And Laniakea itself is just a thread in a cosmic tapestry. Chapter 7. Large-scale structure, the cosmic web. Zoom out far enough, and the universe takes shape like a giant 3D spiderweb. This is called the cosmic web. It consists of gigantic filaments of galaxies, huge superclusters, dense nodes where filaments meet, immense empty voids, millions of light years wide. Each filament is like a cosmic highway containing countless galaxies. Each void is so empty it contains almost nothing, maybe a few lonely atoms. The entire web stretches across the observable universe, shaping everything inside it. It is the largest structure in existence that we know of. But it might not be the largest structure that exists. Chapter 8. Dark matter, the hidden skeleton. The cosmic web you see glowing with galaxies is not the true structure. The real structure is invisible. That skeleton is made of dark matter, a mysterious substance that has mass, creates gravity, does not emit light, makes up 85% of all matter. Dark matter forms giant scaffolds. Galaxies form only where dark matter clumps. Without dark matter, no stars, no planets, no humans would ever exist. The cosmic web is really a dark matter web illuminated by galaxies like small specks of dust. Chapter 9. Dark energy, the force ripping the universe apart. In 1998, scientists discovered something shocking. The expansion of the universe is accelerating. A mysterious force, now called dark energy, is pushing galaxies apart faster and faster. It is invisible, undetectable, everywhere, 68% of the entire universe. Dark energy is the reason why the universe is so huge. It is the reason why distant galaxies are racing away from us faster than light. And it is the reason why we will never see most of the universe. Because every second, more galaxies fall beyond our reach forever. Chapter 10. The true size of the universe, far beyond observation. So far, we've discussed the observable universe, the bubble of space we can see. But what about the unobservable universe? The part beyond the edge of our cosmic horizon. Most scientists agree, the universe is much larger than we can observe. Maybe hundreds of times larger. Maybe trillions of times larger. Maybe infinite. Here are the leading ideas. 1. The universe is finite but unbounded. Like the surface of a sphere. No edges, but no end. 2. The universe is infinite, stretching endlessly in all directions, with countless galaxies repeating again and again. 3. The universe is part of a multiverse. Our bubble is one among billions of other cosmic bubbles. Whatever the truth is, it is far beyond human imagination. Chapter 11. The cosmic horizon, the final wall. The cosmic horizon is not a physical wall. It's the limit of light. Anything beyond 46.5 billion light years is invisible. Not because it's too dim, but because its light will never reach us. Even if we wait forever. Even if we build impossible telescopes. Even if humanity survives for trillions of years. This is the ultimate limit of our vision. The universe could contain 1 trillion galaxies, 1 quadrillion galaxies, 1 Google galaxies, and we might never see them. The universe hides most of itself forever. Chapter 12. The end of everything we can see. Due to dark energy, distant galaxies are not just drifting away. They are accelerating outward. Eventually, we will only see our local group. All other galaxies will fade beyond the horizon. The universe will become dark and empty. In trillions of years, future civilizations may think the universe has only one galaxy. They will never know the truth. Chapter 13. The universe's beginning. To understand how big the universe is, we must understand how it started. In the beginning, the universe was smaller than an atom, hotter than a star's core, denser than anything imaginable. Then, in a fraction of a second, it expanded faster than light. A process called inflation. This is why the universe is so incredibly large today. In fact, inflation may have created a universe that is 10^26 times larger than the observable universe, a number so huge it's beyond comprehension. Chapter 14. Is there an edge? People often ask, where is the edge of the universe? The answer depends on what you mean by edge. 1. The observable edge, 46.5 billion light years away. A limit of what light can show you. 2. The physical edge, unknown. It may not exist. 3. The expansion edge. The universe has no center and no outer boundary. Space is expanding everywhere, equally. Imagine raisins inside rising dough. There is no center raisin. Everything expands away from everything else. The universe works the same way. Chapter 15. Does space go on forever? According to many models, space might be infinite. Time might be infinite. Galaxies might continue forever. There may be infinite versions of you in regions far beyond our horizon. Or, space might curve back on itself. Travel far enough, and you might return to where you started. Just like walking around the Earth. We don't know, and we may never know. Chapter 16. Multiverses. Beyond our universe. Some theories suggest our universe is one bubble in a vast cosmic sea. The multiverse could contain countless universes, each with different laws of physics. Some with no stars, some with no atoms, some with dimensions beyond our own, some collapsing milliseconds after birth. If the multiverse exists, our universe may be incredibly large, but still tiny compared to the full reality. Chapter 17. The final scale, humanity's place. After all these scales, from planets to stars, galaxies to superclusters, cosmic webs to horizons, and universes to multiverses, where do humans stand? We are a moment in cosmic time, on a small planet, orbiting an ordinary star, inside a normal galaxy, one among trillions, in one tiny region of a vast cosmic web, inside a universe we can barely see, in a multiverse we cannot reach. Yet despite being so small, we are the universe trying to understand itself. Final chapter. How big is the universe? So, how big is the universe? The honest answer is, bigger than you can imagine. Bigger than all numbers you can think of. Bigger than all the stars you can ever see. Bigger than all the galaxies that will ever exist. The observable universe is 93 billion light-years across. The actual universe, possibly infinite, possibly one among countless others, possibly far beyond what the human brain can ever comprehend. And that's the beauty of it. We live in a universe so vast, so mysterious, so magnificent, that our entire existence is just one breath, in the lungs of eternity. This is the full story. This is how big the universe really is.